about factoring again. We did this in the first semester, but we're going to go over it again today. Grouping, sum, and difference of cubes. So some of these we haven't done before, but the grouping part we have. So remember, grouping is when you have an even number of terms, and basically for us it's going to be when we have 4 terms. We can group them in pairs of 2. So the steps, you look, factor out the GCF from the first 2 terms, basically pull up what they have in common, factor the GCF from the last 2 terms. If you did it right, the leftover should be the same. This is your first factor, and the GCFs go together to make the other factor. So let's look at example 1, 3x cubed minus x squared plus 15x minus 5. So we're going to look at the first 2, and they have an x squared in common. And the leftovers are 3x minus 1. And then when we do the second one, they have a 5 in common. So we're going to say plus 5, and it's going to have 3x minus 1. So then you can see they have the 3x minus 1s in common. So 3x minus 1 will be one factor, and then the GCFs, x squared and 5, will be the other factor. And so there you go. I actually think it's easier to factor by grouping. It's almost easier than when we have the a times c method. So I really like to see 4 terms because it just seems like it's simpler to do. Let's look at the second one. We're going to look at the first 2 and the second 2. So the first 2 have 3x squared and xy. So we can take out an x, and we have 3x plus y left over. When we look at the second 2, we have minus 12x minus 4y. So in order, I want to have 3x plus y left over, so that means I want to get rid of a minus 4. And when I do that, I'm going to have 3x, and if I take out a minus 4 from here, I'm going to have plus y. So just like before, we can see the 3x plus y's are the same. So that becomes our first factor, and then the GCFs, x and negative 4, become our second factor. So pretty simple. We'll look at this one, number 3. Similar. We have 4 terms, first 2, second 2. So if 25n to the third and 35n squared, they both will have 5n squared in common. And then what's left over is 5n plus 7. So remember, whatever we take out, that's what we divide the inside part by. So 35n squared divided by 5n squared is 7. And then we go to the second part, 30n plus 42. So remember, we want to have 5n plus 7 left over. So how do we do that? Well, look, 42 divided by 7 gives me 6. 30n divided by 5n is 6. So 6 is what we take out. 5n plus 7 is the leftovers. And 5n squared plus 6 is the GCFs. So I feel like once you do a couple of these, it really gets simpler and simpler. You can really see how it works out. The fourth example, so hopefully by now you really have it. 14x cubed, 16x squared. They both have a 2x squared. So hold on, let me get. They both have 2x squared in common. And then left over would be 7x minus 8. And we look at 35x minus 40. Well, they both have a 5, so we can take out a 5, and we're left with 7x minus 8, which is exactly what we want, because now 7x minus 8 is our first factor, 2x squared plus 5 is our second factor. So take a quick look over those four, because I think if you try all four, you'll start to see the patterns that start to show up. All right, so sum and difference of cubes. Think SOAP. So SOAP stands for the signs in here and in here. So if you look, this one is sum, and the second one is difference. So it's a cubed plus b cubed. This one's a cubed minus b cubed. SOAP stands for the signs that you see here, 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 and here. So they stand for same. So the first sign is the same as sum or difference. So in the sum it's plus and the difference is minus. Then second sign is opposite. So if you look in the sum, it's the negative, it's minus, and the difference it's plus. And then the third sign is always positive. So hopefully that helps you remember. So if we look at example here, x cubed plus 8. So in this case, our a value is x, and our b value is 2, because 2 cubed would give us 8. Or you could just rewrite this as 2 cubed, either one. So then we think, okay, so it's a plus b, x plus 2, times x squared, or a squared, minus a times b, which would be just 2x, plus b squared, which is 4. And then if we look at x cubed minus 27, that's like saying x cubed minus 3 cubed. So we're always looking for what's being cubed. And that is just, remember, same, a minus b times a squared, opposite, plus a times b, which would be 3x, plus b squared, which is 9. These are just formulas that you can learn. Okay, let's look at the examples then, individually. Y cubed minus 64. So our a and b are y and 4. So those are what I'm using. So remember, same, then y squared, opposite sign, times ab plus b squared, which is 16. 27m cubed. So the a value here is we have to take 3 and m. That's the a. And the b value is 1, because 1 cubed is 1. So we use the sum formula, a plus b times a squared minus ab plus b squared. So this is a plus b multiplied by a squared, which would be 9m squared, minus a times b, which is just 3m, plus b squared, which would just be 1. Okay, 2x cubed minus 2y cubed. Well, we know 2 isn't a perfect cube, but we can rewrite this as 2 times x cubed minus y cubed. So now it becomes easy. We do 2 and then put it into the difference formula. X minus y times x squared plus xy plus y squared. And the last one, same thing. We're going to use x and we're going to use 2y, because 2 cubed is 8. So it's going to be a plus b multiplied by a squared minus ab, which is just 2xy, plus b squared, 4y squared. So there you go. That is the sum and difference of cubes.